Hello students, welcome to the digital classes. Today we will discuss some interesting numericals in conservation of momentum and Newton's laws. In the earlier classes we have discussed objects in motion, rest, distance, displacement, speed, velocity, equations of motion, v equal to u plus at, s equal to ut plus half at square, v square minus u square is equal to 2as, where u is initial velocity, v is final velocity, a is constant acceleration, s is displacement covered in the time taken t. Also, we have discussed Aristotle in his treatise on the heavens argued that a constant force is necessary to keep the object in uniform motion. Galileo Galilei found that objects in motion would continue to be in uniform motion on level surface unless disturbed by an external agent. We have discussed Newton's laws, which are given in Mathematical Principles of Natural Philosophy by Isaac Newton. The first law of Newton: every object continues to remain in its state of rest or uniform motion until an external unbalanced force acts on it, which can be said as inertia of rest. Object at rest wants to be at rest. An inertia of motion: object in motion wants to be in motion in the same direction. Hence, we can define mass as measure of inertia. We have also discussed momentum, which is mass times velocity of an object. Its SI unit is kg meter per second. Newton's second law, which states that the rate of change in momentum of an object is directly proportional to the external unbalanced force and is in the direction of the force. From Newton's second law, we can find that F is equal to ma. Greater is the mass, lesser is the acceleration, and lesser the mass, greater is the acceleration. And Newton's third law, which says every action has equal and opposite reaction. Here action and reaction mean forces. We discussed balloon pushes the air outside and the air pushes the balloon forward. Rocket pushes the exhaust gases outside and the gases push the rocket forward. We have also discussed free body diagrams, impulse, conservation of linear momentum. Let us demonstrate momentum with some more activities. Here I have a water balloon, here I have a ball. Let us see if we drop what will happen. Now let us drop them independently. This is the height it rises, this is the height it rises. So let us see what will happen if we drop the balloon keeping the ball on the balloon filled with water. Watch it. We will see that the ball rises to a great height, though we have dropped it from a smaller height. This is because the balloon filled with water has greater mass. When it falls down, it falls with increasing speed and it gains more momentum. And when it falls down during the collision, it transfers the momentum to the ball. Ball being lighter will travel with greater velocity. Let us do the same thing with another ball. Watch it. If I am dropping separately, this is the height, but when we drop it keeping one ball over the other, watch it, you can see that the object rises to a greater height. You can also demonstrate with a basketball and a tennis ball. If I drop from the same height, we can see that when we are dropping keeping a smaller ball on the heavier one, and when we release it, the lighter one will go to a greater height. We can try with another ball. Children, let us discuss another activity. Here I demonstrate nailing with a hammer. Here we have a hammer and I have a nail. We can drive the nail into the wood easily using a hammer. Children, here I have a box made of steel, same as hammer, and let me check if I can drive the nail into the wood using this. It is not possible. Why? So, driving the nail into the wood using a lighter object, though it is made of same material, was not possible, because these objects do not have a greater mass, whereas a hammer has a greater mass. Because it has a greater mass, it is easy to drive the nail. It is easy to drive the nail into the wood. So, because it has a greater mass, this part will have a greater momentum, and during each collision a greater momentum is transferred. Greater momentum means greater force. So, more force is exerted on the nail, so easily it is going into the wood. The same thing will not happen with the lighter objects. Another interesting thing, after we drive the nail into the wood, if you touch the wood and see, it is hot. This heat is from the kinetic energy of the hammer. When it was moving, it possesses kinetic energy. During the collision, the energy is given to the nail, and because it stops, the energy comes out in the form of heat. So, we can also see conservation of energy, which we will discuss in the forthcoming classes. Let us discuss some more numericals. Here is a bus which is moving with a velocity 20 meters per second. The mass of the bus is 20,000 kg. Here are some kids on the road. Thinking that the bus is very far, they try to cross the road. But seeing the children on the road, the driver soon applies brakes and stops in 5 seconds. So, what is the braking force? To find out force, we can use the relation force is equal to mass times acceleration. So, acceleration is equal to V minus u by t, which is equal to 0 minus 20 by 5, which gives us minus 4 meter per second square. So, the braking force is given by mass times acceleration, which is 20,000 into minus 4, which is minus 80,000 Newton. Minus sign indicates that the force is in the direction opposite to the velocity. Children, in this example, children thought that they will be able to cross the road before the bus arrives. But children, we have to be very careful when we are crossing the road, because the objects which are moving at very high speed, though they appear to be very far, can arrive in no time. That is, within short span of time they may reach the spot before we cross the road. So, to avoid any kind of accidents, we have to be very careful and we have to take proper precautions before we cross the road. That is, we have to give them stop signal if at all you are crossing the road, and then you have to cross the road. From Newton's third law, we have discussed that every object which is on a ground will experience normal reaction from the ground. Consider this object. This object of mass m is on the ground. Its weight, that is gravitational force, acts downwards, and hence the normal reaction will be equal to weight when the object is at rest. Now, consider an object which is suspended from a height by a rope. Here is an object which is suspended by a string from a rigid support. The weight of the object is mg, mass times acceleration due to gravity, and when the object is at rest, the tension in the string is equal to the weight. When we measure weight using a spring balance, we suspend the object from the lower hook of the spring balance, and then we can get to see the mass of the object on the spring balance given by the pointer. Here is a spring balance. Here a mass of 100 grams is suspended, and then the spring balance has to be suspended from a rigid support, and then we can see the reading on the spring balance. Here the spring balance shows 100 grams. Here is a table with 2 pulleys. Here we place the spring balance, and here we suspend 2 objects each of mass 100 grams as follows. Now guess what reading the spring balance shows. The options are 0 because both the weights can cancel, or the reading can be 200 gram because there are 2 objects each of 100 gram, or the reading can be 100 grams, and the answer is 100 grams. What happens here is, the spring balance, to show 100 gram reading, it requires 2 forces as given in the previous example. The spring balance shows 100 gram when there are 2 forces acting on it. One is the tension which is acting upwards, and the second is the weight of the object which is acting downwards, and then the spring balance shows 100 grams. So, in this case there are 2 forces acting on the spring balance. One is towards left, which is equal to the weight of 100 grams, and the another force is acting on the spring balance, that is towards right, which is also equal to weight of 100 gram. These 2 forces elongate the spring, and hence the reading shown by the spring balance is same as 100 grams. Children, consider another example where we have a pulley and there are 2 objects suspended over the pulley as shown in the figure. Here is a pulley. There are 2 objects which are equal to 5 kg are suspended over the pulley by means of a string as shown in the figure. Both the objects are at rest and released. Will there be any movement now? Option: will the objects move like this? No, the objects will not move like this, because objects are suspended. There are 2 forces acting on each object. One is the tension from the rope, second is the weight. When the objects are at rest, the tension and weight are equal because both objects are equal. So, when the objects are left free, there is no net force acting on the objects, hence they do not move. In the same example, let us make a small change. We keep one object as 5 kg and the other object as 2 kg, and let us see what should happen. Here is a 5 kg and 2 kg objects which are attached to a string and run over a pulley. When the objects are released, what will happen? Of course, because 5 kg is heavier, 5 kg object starts moving downwards and the object 2 kg starts moving up. Not only moving, they also accelerate. For 5 kg object, the weight is more than the tension in the rope, hence it accelerates downwards. For 2 kg object, the weight is less than the tension in the rope, hence it starts moving upwards. Both the objects accelerate. Let us find the acceleration of the objects. Let us find a general formula for the acceleration. Let the masses of the objects be m1 and m2, m1 being heavier than m2. Let the objects accelerate with a constant acceleration a. In case of m1, the acceleration is a and the tension in the string is t. Writing the equation for the object m1, we have m1a is equal to m1g minus t. Here m1g is weight and t is the tension. The unbalanced force, which is equal to m1g minus t, accelerates the object m1, and hence m1a is equal to m1g minus t. Rearranging, we get t equal to m1g minus m1a. Writing the equation for m2, we have m2a is equal to t minus m2g. Rearranging, we get t equal to m2g plus m2a. Solving the equations T equal to m1g minus m1a, T equal to m2g plus m2a, we get acceleration is equal to m1 minus m2 times g divided by m1 plus m2, and tension T is equal to 2 times m1 m2 times g divided by m1 plus m2. So, this is how we can find out the acceleration of the objects which are passed over a pulley. We call this as Atwood machine, and also we can find out the tension in the string. Let us see what happens when a bullet is fired from a gun. Here is a bullet in the gun. When the bullet is fired, the bullet moves with the velocity which is very high. When this starts moving, it pushes the gun back. We call this recoil. We can see another example. When the bullet is pushed forward, the bullet pushes the gun backward. Whenever a gun is held and it is fired, the gun comes back. This is called recoil. So, whenever a bullet has to be fired, the gun has to be held properly with force so that we can withstand the recoil. So, let us see how the gun has to be held. Here are 3 men who are holding the gun. The first one holds the gun far away from his body, and the second one holds the gun with one hand. In both the cases, they will not be able to withstand the recoil of the gun. The gun has to be held tightly to the body, and then bullet has to be fired. In this case, the person can withstand the recoil. Now, let me explain the same case with the numerical. Here is a gun whose mass is 10 kg. Mass of the bullet is 50 gram. The bullet is fired with a speed of 100 meters per second. The recoil of the gun has to be found out. So, we have to use the principle of conservation of momentum, which says the total momentum before any collision is equal to total momentum after collision, provided there is no external force. The principle of conservation of momentum, from which we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. The total momentum before collision is equal to total momentum after collision. Here m1 is mass of the gun, which is 10 kg. Before collision, that is before firing, initial velocity is 0. After bullet is fired, we have to find out its velocity, that is v1. The mass of the bullet is 50 gram. Writing in kg, it is 0.05 kg. Initial velocity was 0, that is u2. When the bullet is fired, the velocity was 100 meters per second. Substituting the values in the equation, we get 0 equal to 10 v1 plus 0.05 times 100. Simplifying, we get 0 equals to 10 v1 plus 5. So, we get minus 5 equal to 10 v1, and v1 is equal to minus 5 by 10, which is 0.5 meters per second, and the negative sign here indicates that the gun travels in the direction opposite to the velocity of the bullet. So, 0.5 meters per second, when we write in centimeters, it is minus 50 centimeters per second. So, when bullet moves at 100 meters per second, recoil of the gun is minus 0.5 meters per second. Let us explain the second case, that is when the man holds the gun tightly to his body. Here is a man who is holding the gun tightly to his body to withstand the recoil of the gun. So, mass of the man is 70 kg. Let us say mass of the gun is 10 kg. So, total mass of man and gun is 80 kg. So, now using the same principle, that is conservation of momentum, initial momentum is 0, final momentum will be 80 V1 plus 0.05 into 100, which gives us 0 is equal to 80 V1 plus 5. So, minus 5 is equal to 80 V1 and V1 is equal to minus 5 by 80, which is minus 0.0625 meters per second. In centimeters, it will be 6.25 centimeters per second. If we hold the gun away from the body, so the recoil is 50 centimeters per second, whereas holding the gun tight to the body, the recoil reduces to 6.25 centimeters per second. Look at the man, how he is holding the gun. The man holds the gun tightly to his body so that the effect of recoil is reduced to a great extent. Let us demonstrate another activity to demonstrate momentum. Here I have a piece of paper in the bottle. Though the bottle is empty, here I have a paper and I want to push the bottle with the paper. Paper is not hard enough, so this is not able to push the bottle. Or for rubber band, I give paper enough momentum. So, I fold the paper. So, using the rubber band, I give paper enough velocity. Using a rubber band, we can give enough velocity to paper so that it has more momentum. So, when the paper is moving with a greater velocity, it has enough momentum to throw the bottle down, or if it hits, then we get hurt. So, children, do not repeat this activity. This was only for understanding of momentum. Let us solve another question. A man of mass 30 kg uses a rope to climb which bears only 450 Newton. What is the maximum acceleration with which he can climb safely, given that acceleration due to gravity is 10 meter per second square? Here is a man who is trying to climb up the rope, but the rope can withstand a maximum tension of 450 Newton. First, consider mass of the man. So, his weight will be mg, m is mass, g is acceleration due to gravity. So, 30 times 10 gives you 300 Newton. Let the acceleration be a. Tension can be maximum of 450 Newton, and which will be equal to mg plus ma. So, tension is 450, which is equal to 300 Newton plus 30 times a. So, 30a is equal to 450 minus 300. 30a is equal to 150, which gives us acceleration equal to 5 meter per second square. So, the maximum acceleration with which a person can climb up this rope will be 5 meter per second square. Consider another numerical. A force of 10 Newton acts on two objects of masses 3 kg and 2 kg at rest. Find the force which 3 kg object exerts on 2 kg object. So, force of 10 Newton acts on 3 kg. In turn, 3 kg applies force on 2 kg object. Exactly the same force, that is reaction force, will be applied by 2 kg. 2 kg applies equal reaction force on 3 kg. To find out the force, we need to find out the acceleration, that is force by total mass. Force is 10 Newton, the total mass is 3 kg plus 2 kg, which is 5. So, acceleration is equal to 2 meter per second square. Force on 2 kg is equal to ma, which is 2 times 2, which is 4 Newton. Let us revise. Newton's first law says every object continues to remain in state of rest or uniform motion until an external unbalanced force acts on it. Newton's second law says the rate of change in momentum of an object is directly proportional to the external unbalanced force and is in the direction of the force. Newton's third law says every action has equal and opposite reaction. We have seen normal reaction acting on an object which is on a surface, which will be equal to the weight of the object. We have learnt free body diagrams. We have seen conservation of linear momentum. When no external force acts, the total momentum before collision is equal to total momentum after collision. We have seen the force generates an acceleration on an object of mass m. We can find it from the relation F is equal to ma. We have discussed impulse, which is change in momentum, which will be equal to force times the time. We have discussed Atwood machine, and the acceleration of the objects which are moving will be given by m1 minus m2 times g divided by m1 plus m2. The tension T is given by 2 m1 m2 g divided by m1 plus m2. Children, we have discussed laws of motion, momentum, conservation of momentum. What I want you people to do is observe the objects which are moving in your day-to-day life and try to give proper reason why they are moving or how they are moving, or try to predict the motion of the object in various situations. Not only that, take the textbook, work out the numericals which are given at the end of the textbook, and discuss the topics with your friends, and if you have any doubts, get them clarified from your teachers. Let us meet in another session with an interesting topic. Thank you.
ఇతరులపై ఎక్కువగా ఆధారపడే వృద్ధులు, వికలాంగుల మెరుగైన జీవనానికి సహాయపడే ఆవిష్కరణ మీ దగ్గర ఉందా? అయితే మీకోసమే తెలంగాణ స్టేట్ ఇన్నోవేటివ్ సెల్ వేదికని ఏర్పాటు చేసింది. నిత్య నూతనమైన మీ ఆవిష్కరణల్లో ఊతకర్ర మొదలు రోబోటిక్స్ వంటి సంక్లిష్టమైనవైనా, వినికిడి, దృష్టి, శారీరక సహాయం అందించే ఆవిష్కరణలేవైనా సరే మోడల్స్ ప్రదర్శించగలిగి వృద్ధులు, వికలాంగుల జీవితాల్ని ప్రభావితం చేయగలిగితే చాలు. పూర్తిగా ఆన్లైన్ వేదికగా జరగబోయే సహాయ సాంకేతిక ఆవిష్కరణల ప్రదర్శన 2020లో విద్యార్థులు, స్టార్టప్ కంపెనీలు, ఆవిష్కర్తలు ఎవరైనా పాల్గొనవచ్చు. మీ ఐడియాను మరింత మెరుగుపరుచుకునే మెంటర్షిప్ తో పాటు మార్కెటింగ్ అవకాశాల్ని వృద్ధిపరచుకోండి. నవంబర్ 14 లోపు www.teamtsic.org/@summit లో మీ వివరాలు నమోదు చేసుకోండి.
పండుగ పూట మాస్క్ వేసుకో, సంబరాలు చేసుకో, సబ్బుతోటి చేతులు కడుగు, కరోనాను కడిగి, గుంపులు గుంపులుగా చేరి కరోనాను పంచకు, ఇంట్లో ఉండి అందరికీ ఆనందాన్ని పంచు.
ఈ పండగ వేళ మన శుభ్రతే మన భద్రత.
జారీ చేసిన వారు సంచాలకులు, ప్రజారోగ్య మరియు కుటుంబ సంక్షేమ శాఖ, తెలంగాణ ప్రభుత్వం.
ఆరోగ్యమిత్ర. ఆస్టియో ఆర్థరైటిస్ అంటే ఏమిటి? ఆస్టియో ఆర్థరైటిస్ ఎవరిలో వస్తుంది? ఆస్టియో ఆర్థరైటిస్కు రుమటాయిడ్ ఆర్థరైటిస్కు తేడా ఏమిటి? ఆర్థరైటిస్ వంశపారంపర్యంగా వస్తుందా? ఆర్థరైటిస్ నియంత్రణలో ఫిజియోథెరపీ పాత్ర ఏమిటి? ఆర్థరైటిస్ రాకుండా తీసుకోవాల్సిన జాగ్రత్తలేమిటి? ఇలాంటి మీ సందేహాలన్నింటికి ప్రముఖ రుమటాలజిస్ట్ డాక్టర్ పిఎస్ఆర్ గుప్తా గారి సలహాలు, సూచనలు ప్రత్యక్ష ప్రసారం నవంబర్ 13వ తేదీ శుక్రవారం సాయంత్రం 4 గంటలకు మీ టీశాట్ టీవీ నిపుణలో. సంప్రదించవలసిన మా ఫోన్ నెంబర్లు 040-235-800-425-4039.